Hi all, welcome to the JavaSig meeting today. Hope you're all doing well. We had a great meeting last time. It was the 25th anniversary special. Welcome back again. We have a very interesting speaker today here with us, who's Josh. And before we start off with Josh's talk, so a few quick announcements for you. If you would like to receive more updates from us, be posted about what's happening, please follow us on our Twitter handle, which is at nyjavasig. And please head over to our website, javasig.com, and subscribe to our mailing list so that you can be informed about all the upcoming events, or you could just send a blank email to our JavaSig email, and you would be registered automatically. So today we have Rodrigo with us, who's going to give us an interesting update on our epic meeting that happened last time. Rodrigo.
All right. Thank you, Sai. So as I said, we had a very interesting meeting last September 23rd. It was our 25th anniversary meeting. We had a big crowd. Our panelists were awesome. So we had James Gosling, Brian Goetz, Venkat Subramania, and Shared Sander. They represent some of the most important names within the Java community. And I want to thank personally, and in the name of the NY Java SIG, their presence to the events. We have received a large number of questions from our members, and some of the best questions they were asked to our panelists during the events. Thanks to our sponsors, we had a big giveaway. It was over 40 books, software licenses, Java coins, and many others. So if you miss the event, you can watch the recording at the NY Java SIG YouTube channel. And I think it was very interesting. And some of the highlights of the events that I captured, I think, did you know that Java was not the first option of the name of the language? It was the fourth option. And didn't work out because of some issues with the attorneys and everything. But and James Gosling, he mentioned that his favorite name was Lyric. So that's very interesting. I didn't know about it. I don't know if you know about it, but for me that was new. Our panelists they're very excited for the upcoming changes to the Java language, and they mentioned two projects in special: Project Ember, which started in 2017 and has features like the local variable type inference, the var, right? Some change to the Lambda, and more recently, pattern matching, records, seal types, and text blocks. And also, the other mention was to Project Loom. I think there's a lot of noise on Project Loom, especially fibers with lightweight threads. And so those are some of the features to keep your eye on. I'll quote something that Brian said. He said, "I'm really looking forward to Project Loom. The essence of the Project Loom is to go back to what threads were in the first place." And Venkat, he also said, "The reason I'm excited about Project Loom is the structure of the synchronous code can now be the structure of a synchronous code. And that makes my mind blow." So that's something very interesting. I think every developer should keep an eye on Project Loom. There was also a consensus that the Java became why Java is the #1 language of so many developers. And as Charles said, you don't just build technology, you build an ecosystem that fosters the technology. And I think our community, something great about it, it's sharing. I think we share, that's what makes Java so special. It's we build content, we share content, and we help each other. So I think that's definitely one of the strong points about Java. And for those who said that Java is dead, I have a few numbers. There are somewhere between 9.5 and 10 million Java developers, and they're not the developer that's sitting in their house and they don't have Java as their main job. So we have 10 million people that work with Java consistently. They are paid to work with Java, so that's huge. No other language has that. We have above 300 Java champions, and Java champions are Java people very important, recognized by the community, people that talk about Java, that promote the language. We are glad here on the Jug that we have a few Java champions. We have Jean Boyarsky, we have Frank Greco, we have Chandra Guntur. Josh, that we'll present later today, is also a Java champion. So it's your work that you do is very much appreciated. And the number of Java user groups of somewhere between 350 and 400 Java user groups around the world. So Java is definitely not dead. So long life to Java. Thank you, Sai. Back to you. You're on mute, Sai.
Thank you, Rodrigo. That was a great summary of the event from last time. Like you said, we really had a rockstar panel with us, and thanks to Jean, she was a great host. Asking very interesting questions. That's great. So now let's move on to a very fun segment. We have Jean here who will walk us through the trivia today.
Hi, everybody. We have 4 questions for you to answer before we can get to Josh. So remember to answer them because I'm standing between you and Josh Long. I'm also hoping that you'll learn a couple things along the way. Our first trivia question is whether this is your first JavaSig meeting. We know that some of you joined us last month for the first time. And we also know that we had some people who watched on video for the first time, and this is their first live meeting. So we're curious to see whether this is your first meeting or not. Make sure to vote on the link that is in the YouTube chat so that we can see if you've been here before or if you're brand new to the user group. You know, everybody's busy going where they're opening a chat right now, and then they're clicking on the link, and then they're voting. It's all very exciting. All right, awesome. Looks like we've got a couple of new people and a lot of returning people. For our next question, we want to learn about what version of Java you're using. Now, you might be on a modern version of Java, like 11 LTS, or you might even be on the non-LTS version, like 12, 13, or 14. You might be like the masses and be on Java 8 LTS, or possibly 9 or 10, it's pretty less common. You might be sad and be on Java 7, 6, or even 5. I pray nobody's on 5. Please don't be on 5. Shouldn't even be on 7 by now. Or you could be really bad and be on Java 1, 2, 3, or 4. And if you are, I think all hope is lost. I don't know what we would do with such a thing. So let's see how people are voting on their versions of Java. Interesting stuff. Looks like Java 8 is still in the lead. One day that's going to change. I know one day that's going to change. One day we're going to be in a position where we are all on later versions of Java, and then we are going to be on the latest LTS, and it's going to be so exciting. That's just great. So let's take us to our third trivia question. Our third trivia question is about a piece of code which I did not have the foresight to make a PowerPoint for, so I'm going to tell you what it is out loud. It's going to be fun. Also, I see everybody's voting in the chat. What we're going to try for this next one really hard is that you're going to click on the Menti link in the chat, and you're going to click on that. So the first piece of code is a URL. It's getting the URL for Google, and based on that URL, it's getting the URL for Google again. And then it's seeing whether those 2 URLs are equal. So what do you think happens here? Do you think it prints true? Do you think it prints false? Or do you think it depends on something that is not yet known? Interesting stuff, right? We're good programmers. It depends. I like it depends. And for those of you who are wondering where this code is that I'm reading, it's in the Menti URL. So if you actually click on the Menti URL that I'm trying to get you to use, you can read the code. Super secret plan, right? Okay, let's see how people have voted. Okay, awesome. People have conquered the Menti poll. They're actually voting there. And it's neck and neck between true and false with one, it depends. The answer is in fact true, which is good. Google hasn't moved. We expect Google to be Google and to be able to make decisions based on that. And I'm pleased to say that majority of you did in fact get that right, just barely. Now we're going to take a look at a piece of fairly similar code and see what happens there. So in the similar code, we have another Menti poll. This time we have the same bit of code, except this time we have a cloud URL instead of Google. Do we think that changes the behavior? Again, our choices are true, false, or it depends. And this time I'm expecting to see the same number of votes in Menti because now I know you know how to use it. Clever, right? Tick tock, we're all voting. And I see some early results starting to come in. Our choices are true. People are recognizing that this is intended to be a different. This time I'm expecting to see the same number of votes in Menti because now I know you know how to use it. Clever, right? Okay, that was not me. We have most people voting no, and we have a few it depends. The answer is, in fact, it depends. You get a mixture of yes or no, and it depends on your cloud provider and how they do DNS resolution, which is not the ideal scenario. The lesson is that you should be using URI instead of URL, because if you use URI, it behaves predictably, which is what you want to happen in code. Now that you've all learned something, I'd like to turn it back over to Sai to introduce our speaker.
Thank you, Jean. That was a very interesting trivia. The URL problems are quite interesting. And it's good to know how the validation occurs and the Java API is able to clearly help the developers understand which are valid URLs and which are not, and then throws valid exceptions. So it's great. So now let's head over to introduce none other than Josh Long. If you all remember, 3 years ago, Josh was at JavaSeg. We were all at Pivotal's place, and Josh had a very interesting talk at that point of time. And he's back again. We're really looking forward to his talk today. He's going to speak about reactive sockets. Josh is a very famous person. You all might know already. He's spoken at so many different conferences. He's a Java champion, as Rodrigo mentioned earlier. He contributes a lot to open source, and he's a celebrated author. He's written so many books, including on topics like Cloud Native Java, Reactive Spring, Spring Cloud, Cloud Foundry, and he also does podcasts. And if you all have seen his Twitter handle before, it's impossible to forget it. Kudos to him for coming up with a very creative Twitter handle. Over to you, Josh. You can start sharing your screen.
Okay. Share screen. Good stuff. All right. All right, everybody. Good afternoon, good evening, good morning, whatever. How are you? I appreciate you all coming here. I appreciate that we are here together. I know there's a lot of places you could be, but if you'd all hang out with us today, that's awesome. Thank you for that. Hold on one second. Actually, yeah, come on. Please. Okay, sorry. Okay, so I appreciate you're all here. I really appreciate the opportunity. Obviously, I know there's a lot of places you could all be today, but instead you chose to hang out with us. That's really appreciated. A little bit about myself. My name is Josh Long. I work on the Spring team. I'm a Java champion, a Google developer expert for Kotlin, and of course, a Spring developer advocate. And I'm online, very tuned in, plugged in, all that stuff. So find me on the internet if you have questions. Obviously, there's my Twitter. My direct messages are wide open. I'm happy to answer questions. And there, of course, is my email. Should you have comments, feedback, questions, whatever, I'm all too happy to receive it, all too happy to engage. I used to be a little bit more async because of travel, but that's not a thing we do these days. So, hey, who knows? I might be a little bit more prompt in responding. I do try and get to everything that people send me. I work on the Spring team. As part of that, I've been around the block once or twice. I've done some videos, as was just mentioned. There's a number of different videos out there and more coming. I wrote a book a few years ago called Cloud Native Java, which is all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. I have a podcast, as we just mentioned, called a Bootiful Podcast. You can find this on the wherever fine podcasts are purveyed. I have a blog called This Week in Spring. It's every Tuesday. That's today, friends. That's what I'm going to be working on as soon as we finish our time together here today. Every Tuesday, it's just me rounding up all the news that's fit to reprint in the Spring ecosystem, and there is a lot usually, so it tends to be pretty lengthy. I've been doing that every week, every Tuesday without fail since January 2011, right? So there's a lot of stuff. I wish nothing happened just for a minute, but there's always something interesting and new and cool in that ecosystem. So there's that. I do a screencast, and I tend to do a season of 11 episodes plus a roundup episode or a blog. And that's, 12 bursts in a row, and then I take some time off. So there's been, I think we're on season 7, maybe, I'm not sure. I'm working on the new stuff. I just don't remember the season number. I've got a book that just came out called Reactive Spring, and Reactive Spring is all about how to build applications that take advantage of reactive APIs. Now, reactive APIs answer two questions. They answer two very simple questions. The first of which is, hey, now that we're all in this world of microservices, now that we're in this world where distributed actors need to talk to each other over the network, now that we've invited that complexity, what is the programming model that I can use to better take advantage of that concurrency, of the sort of agency that each service has, and that might cause issues when we have to coordinate with others in the system. There's volatility, there's control flow issues. And so I want a better way to handle that sort of inherent complexity. The other thing it gives us is a way to say, here is something that might end up sitting on a thread, which I can't afford. I want to be able to jump off of that thread. And so reactive programming gives us a programming model where if I want to, I can write code that is more resource efficient. And I can do that today. I can do that since Java 8, basically, right? That's one of the really nice things. And of course, in the future, when it comes to Project Loom, that'll just be yet another scheduler you can use in this, right? I like reactive APIs because they give me a programming model. One second. It gives me a programming model that I can use to describe inherently latent, inherently asynchronous, inherently volatile things in the world. So I like reactive APIs. I like reactive programming. I like reactive programming with Spring. So in order to appreciate that, we're going to take a brief tour of all things reactive, and then we're going to dive into something called RSockets. Now, RSockets are, I think, one of the more compelling features in the ecosystem. They give us the ability to write reactive code, to write code that has all the features of reactive APIs without actually sacrificing, inherent flexibility and the inherent speed of binary protocols on the wire. So let's go ahead and shut this down. Don't want to save that. And we're going to go here to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a brand new application, taking advantage of all the latest and greatest defaults. I'm going to just create this, and I'm going to call this service because I'm good with names. I'm very good with names. You can see that in the way that I name my artifacts. Down here, my friends, when you scroll down just a little bit at the very bottom of this screen, well, actually, at the very top, you've got three choices, three options here. I encourage you to take advantage of whichever you like. Obviously, Java is a very interesting language, and it's growing by leaps and bounds for a lot of people. So there's a great solid selection there. But there's also Groovy, very nice language as well. Kotlin as well. I love Kotlin as well. So all of these are just fine. And actually, if you're using Kotlin, you're going to find that it has already a nice syntax for coroutines. Now, coroutines map more or less to the async await keyword that was first introduced in C#, 12, 15 years ago, and that has since found its way to languages like Rust, Python, Go, and JavaScript. Even JavaScript, and C++. Awkward. Anyway, we have that really nice syntax there, and that gives us a nice way to write imperative code that is behind the scenes doing asynchronous things, right? It's a generic mechanism that everybody can take advantage of. And hopefully one day we'll see something like that in Java. I think that'd be really nice. So Kotlin, Java, whatever, everything that we're going to look at today is going to take advantage of reactive APIs. And by extension, everything that we're going to look at can also be written as a coroutine, because everything in our integration for coroutines builds ultimately on these reactive APIs. So if you understand what's happening with the reactive APIs, you understand inherently what's happening with coroutines. We're going to use the latest and greatest version of Spring Boot. That's fine. No particular reason to change that. we're going to choose a version of Java. Now here, my friends, we have before us 3 choices, and I use air quotes here because I want to convey to you how ridiculously the phrasing of that is. When I say choices, I say you have 3 possible things you could select, but really, being honest with ourselves, there's only 2 things that you should select. Only 2 things that you really, in 2020, could select. The first of which is Java 11, which is the default. That's the current long-term supported version of Java. That's the version that you're going to be using today in 2020 if you're doing it right, right? Java 11's, and barring any particular reason to move forward, that is to say. Java 11 is a nice addition. It's got a lot of nice features, a lot of language syntax that I quite like. So it's a reasonable default. And it's got the benefit of being long-term supported. That said, Java 15 is the current version of Java, and it'll be around for another, 4 months, something like that, 5 months. It's a fairly new version. It's a nice addition, and you can choose that, and that's what you should be using, my friends. These are the only 2 versions of Java that you can be using in 2020. You should not and could not be using Java 8. Java 8 is no longer a technically viable version of Java language to use. It's old, it's decrepit, it's ancient, it's creakingly old. The security and the syntax and everything else and the performance are all way behind the curve. To use that is inexcusable. Now, I know that some of you may be tempted to click on this. Don't do it. Resist that urge. Do yourself a favor. Trust me, my friend, you're not ready for that conversation. You're not going to want to have to talk to your children and explain to them why you're still using Java 8 in production. That's not a conversation any parent should have with their kids, and you don't want to be the first. Instead, you want to use the current version of Java at the very least, or the long-term supported version. I am happy with anything, as I've got Java 15 running on my local machine. Java 11, like I say, it's an acceptable, if cowardly, version of Java to use. If you're using a cloud platform, those cloud platforms will happily conveyor belt you to the next version of Java, in which case you really have no reason to fear using 15. So either way, choose what you like. I'm going to bring in some dependencies here. And we're going to start quickly. We're just going to start with a quick discussion of reactive APIs using the reactive web support. We're going to use RSocket. We're going to use Lombok. We're going to use Spring Security. And I think with that done, I think I'm satisfied with my selections. Let's just review here. Do I have everything I need? Looks like I might, looks like I will, so that's fine. Let's go ahead and hit generate. I'm going to open up this project in our IDE. And again, it doesn't matter what IDE you use, so long as it supports the version of Java that you're using. And come to think of it, I'm not even sure if my IDE does, because I'm not using the latest and greatest IntelliJ. There, some risks, but Java, there's no risk. You can just upgrade. It's a nice piece of technology. Let's see. So first things first, before we dive into RSocket, let's just talk about reactive APIs. I really want to make sure we're all on the same page as concerns reactive APIs, because without that, we have no foundation on which to proceed. Let me make the font larger here, friends. I appreciate that. That can look a little small given the ratios and the screens and all that. So 24, I think, is pretty sufficient, hopefully. Let's just do 26 to remove any shadow of a doubt. There we go. Okay, so now I've got a brand new application, and this application is just a regular Spring Boot application, but I don't want to spend too much time talking about Spring Boot just yet. Let's just ignore the discussion of Spring Boot, and let's just talk about reactive APIs, okay? So I've gotten rid of all that, and what I want to do is I want to introduce to you a few types. Let's say that I wanted to create a reactive stream of strings, okay? String of IDs. So here I've got a type called a flux. A flux comes from Project Reactor. So here's Project Reactor. Reactor is a library that's designed to support reactive APIs and service composition in the Java ecosystem. It was built by the Spring team back in 2011. It is similar, but not identical, obviously, to things like RxJava or to Akka Streams or to Vertex or whatever. It's a foundational thing on which somebody can build something more full featured to satisfy our everyday sort of bread and butter business logic concerns, things like security, data access, web services, etc. So I have a flux. A flux, like I said, comes from Reactor. It is ultimately an implementation of a type called a publisher. A publisher is a thing that produces data asynchronously out of band for a subscriber to consume. It is part of the org reactive streams package. Now this package is a sort of a common ground place for foundational types that were the result of an effort by the Spring team, right? Then at VMware and then Pivotal, Lightbend, then called TypeSafe, Netflix, and the Eclipse Foundation. And we got together and we said, let's find a way to identify common ground interfaces that help us describe things that will be available eventually. They're not here right now, but they'll be here in the future. They might be here in the next nanosecond. They might be here immediately, for all we know, or they might be here in a year, right? And by the way, they could be here immediately. That's just a function of which scheduler you run it on. If you run it on the same scheduler as the client thread, then it's effectively synchronous, right? But now you can have both. You can say, I want to use the same API to write effectively synchronous code, or I can write asynchronous code. And you've got one kind of thing, one kind of stuff. This is important. That consistency makes it much easier to build services that compose well using reactive APIs, as we'll see in just a second. So a publisher publishes data asynchronously out of band to a subscriber. The subscriber, when it first subscribes to the publisher, is given a subscription. This is super important, and we'll talk about that in just a second. When there are records to process, they are given to the onNext method. When there are errors to handle, they're passed into the onError method. And the onComplete method is what's called after the stream has finished emitting all the data it's going to emit. Now, let's talk about this subscription thing here. The subscription represents the session that a client has that represents the state of the reactive stream from the publisher. So the subscription is what the client will use to say, hey, publisher, hey, thing that's giving me data, please don't give me any more, or please just give me 10 more records or 1,000 more records or whatever. The subscriber says, hey, I want to request 12 records. I can ask for 12 or 15 or whatever more records. This is very useful because now the client, the thing that's consuming the data, is in control of the rate of consumption. It is in control of how fast this asynchronous thing, which is going to produce data eventually, is going to drop that data in my lap to handle. Okay, this is very, very useful. It's called flow control, and it's not a new idea. It's just that we surfaced this as part of the API. But again, not a new idea. Ever since we had one computer on the same network talking to another, we've had to worry about flow control. Not a new thing at all, right? This is 80 years in computer science history, at least. So, good stuff, right? Subscription, I can now request more data, and if I don't want any more data, I can cancel. This is sometimes called back pressure, right? I just said flow control because that's a thing I think most of us have heard before. It's something with which we're mostly, hopefully, knock on wood or whatever the component substance of this table is, familiar. That said, you might hear it called back pressure. It's the same idea. It's interchangeable. It just says when I, as a subscriber, am overwhelmed, I can push back by either not requesting anymore, in which case I'm kind of hitting a pause button, or I can just stop the processing altogether by canceling, okay? Now, finally, I said there's 4 types. There's a 4th type. It's called a processor. And processor is a bridge. It's a source and a sink. It's a publisher and a subscriber. It's just a bridge. And that's it, my friends. Those are the 4 types. That's part of the reactive stream specification. These types are, as you can see, foundational. They're very, very simple. They're just the beginnings of something. So you need something like Project Reactor to sit and make those more approachable. But they are super useful. They're obviously useful. So useful, in fact, that they're actually part of the JDK. So if you go to Java util concurrent flow, you can see that they've since been incorporated in here. So Java util concurrent flow.processor. Java util concurrent flow.subscription, Java util concurrent flow.subscriber, and Java util concurrent flow.publisher. So good stuff, right? Like for like method signatures and everything. Obviously the package and the namespace is different, but there are adapter types that you can use, right? The reactive streams specification itself comes with a type that you can use. So if I go to this library, you can see there's a flow adapters, and this has some static methods that you can use to turn a reactive stream adapter, reactive stream publisher, which works with anything Java 8 or later, to a Java 9 flow publisher, and vice versa. Okay. Now I will probably use the reactive streams types, but it doesn't matter, right? You can see it's cheap to move back and forth from one to the other, so it's interoperable, interchangeable, etc. Now I've got a foundational layer, but like I said, there's still a gap. There's still stuff I want to be able to do with my APIs. I can ask for data and I can cancel the data. That's about it, right? Most of us are accustomed to having more robust operators with which we can describe the data flow from one thing to another. And this is where,
I promised I'd only interrupt you if it was urgent. We got a comment that the font is too small.
No problem. Let's see, 30. Is that better?
Yeah, that looks a lot better. Thank you.
Okay, happy to help. Okay, so what I want is a more robust set of operators on top of these foundational reactive streams types. Most of us are accustomed to the rich operators that come with something like the Java 8 Streams API, right? The Java 8 Streams API is more of a functional style of processing. We use it to process synchronous, sort of in-memory buffers of data, but nonetheless, it's a very convenient sort of functional style that we can use to process data. So we want something like that. And this is where Project Reactor, which, as I say, builds on top of the reactive streams spec types, comes into play. Project Reactor provides two types, the first of which is a Flux. A Flux is a publisher, sure, but it's also got a lot of operators. You can see there's a lot of code here, some of which, I will probably never see in my life just because there's so much of it, right? These operators provide things you can use to make working with reactive streams easier. Things like filter, map, flat map, etc. There's also another type. So let's say this is null, to do. Okay, there's another type here called mono, right? And it's maybe I'll have mono ID, right? So here, a mono is also a reactive stream type, right? It comes from Reactor. It extends publisher, or implements publisher rather, but it is a single value. So it's kind of like a completable future, except that it has back pressure. And a flux of something is kind of like a stream, except that it has back pressure and the scheduling is built in, right? The runtime scheduling for efficiency. So very consistent, they're both publishers, but one has a semantic difference that's useful in distinguishing it from the other. The first is that it handles 0 or 1 values, that's the mono, and the second has 0 to n values, where n is potentially unbounded. With these types, I can describe all sorts of use cases. Let's suppose I have an interface or a service or something, and that service or that interface of the service is, CRM client, right? And I have a class order, okay? I want to return all the orders, right? I can get all the orders from there. So that tells me that's going to give me everything. On the other hand, if I say, give me a mono of order, get order by ID, then somebody's expecting to provide a single value. I'm supposed to be able to pull back just a single instance of that thing, right? And that's clear in the semantics. Whereas if somebody gave you, a publisher, you wouldn't know which is which. You wouldn't know whether this is the details of a particular one or if this is like the overview, overview page or something like that. So these types, very, very convenient. They give us a lot of operators, as we'll see, and they allow us to do a lot of interesting things. Now remember, anything in the reactive world will give you one of these two types back. That's where things get really powerful, is that you can use and rely upon and learn these types and take them with you anywhere. Suddenly, life becomes much simpler. Sure, there's a slightly uphill incline when it comes to first learning these types. I'll grant you that, just as there was when you learned the Java 8 Streams API, for sure. That said, once you've learned these, suddenly a whole category of problems go away. Do you want to do WebSockets? Great, you use a publisher. You want to do service and events? You use a publisher. What about just returning a single string from a REST endpoint for application JSON? You use a publisher. What if you wanted to do a Kafka? You want to consume messages from Kafka? You use a publisher. What about RabbitMQ? Ditto, you use a publisher. What about WebSockets? You use a publisher. That's the beauty of this now. Suddenly, all these different APIs that we have in the Java ecosystem, each of which is slightly different and each of which has slightly different ways of saying the same thing, suddenly all those melt away. You're not dealing with 10 different APIs to say, hey, here's the thing that's going to give me data asynchronously in the future at some point, I don't know when, and I may want to push back on it. Now you have it all just built in, right? This is where you get into this is where you get a lot of win, right? Okay, so I want to use these reactive types. They give me the ability to do that. What I want to do now is I want to compose these reactive types. So I'm going to say, let's say I've got a stream of orders. Okay, so let's say I've got a publisher that's giving me a stream of orders. And again, it doesn't matter how we get this reactive stream. You can get it from a repository, you can get it from making a REST HTTP call to another service. You can get it from all sorts of places in the world. It's sort of immaterial. What we care about is what we can do with the result that we get, okay? So now I've got a reactive stream of order entities from some service or some data store or whatever. And the first thing that comes up is, okay, well, what if something goes wrong? Well, of course, I can, let's just say that this is an empty stream. Okay, let's just say it's an empty stream. But let's say that instead, let's just imagine that this came from some other network service. Once I have a stream, okay, I can actually do some interesting things. I can say, okay, I want to retry the call. If something should go wrong, retry. Or if something should go wrong, I want to retry 10 times. or something should go wrong, I want to retry 10 times while also backing off each time, waiting a little bit longer, right? I can do interesting things like retries. I can do timeouts. I can say I want to timeout if something exceeds that amount of time. I just want to stop doing it, and I'll just pull, I'll cancel the stream and I'll try again or do something else or degrade gracefully, right? I can also say what happens if there's an error. I can say on error resume. So should there be, let's say, an illegal access error or whatever, right? Then I'm given a pointer to the exception, and it's my job to return, some value in lieu of the original stream that I was expecting. Oh, it's I'm supposed to return a flux of orders. So I can just do empty. There you go, right? Or better yet, return an error, right? I can say, here's my error. I can propagate it. I can do whatever I want. There's lots of different things you can do there. So I've got now a reactive stream. And remember, the result of this is a reactive stream, right? So I still have a reactive stream. It's not any different from what I had here before. It's just that now I've got all these operators that are built in. I don't have to have some framework that layers in these extra things. They're just built in, right? This actually makes some of the things that people build into their microservices API less relevant. And that includes some of the bits from Spring Cloud. I'm happy to say that, right? Some of the bits from Spring Cloud that were so novel when they first came out 5-6 years ago are now less interesting because they're just done for you by the Reactive API. They make building network services more reliable, more robust. And this is what you want. So now I've got a stream of orders, okay? And I've done everything I can to make sure it's gonna work. But let's say I'm making a network call to some other service, right? Calling network service. And I'm calling another network service. And as I call the other network service, I run the risk of something going wrong. So I call service 1, I call service 2, I call service 3, and I want to make sure that I get a result back in time. So a lot of organizations, what they'll do is they'll call service A, they'll get the results back in time, and then they'll process it, right? And they'll hope that the result that they get back comes back in the time that they need in order to satisfy their SLA. But what if that result takes longer than they expect? Well, then you've got your timeout, right? But even there, what can you do now? Hopefully you're not dividing or doubling rather the SLA for somebody else upstream, right? Imagine if your SLA for the client that depends on you is some, just for a nice and generous number, 10 whole seconds, right? 10 whole seconds is a long time for people to wait. Hopefully that's not what's happening. But what happens if your SLA is 10 seconds? That means that you are expecting the result that you're expecting to come back within 5 seconds. That way, if they time out, if they exceed their budget, you can still try it one more time, right? That's at least one more time. You probably want more than that. So now you've made it so that the downstream service is pressured. They've only got 5 seconds in which to do the work that they're trying to do, while you have an indulgent 10 seconds to get the work done. Goodness knows what's going to happen to the poor service downstream of that service, right? Now it has to respond in 2.5 seconds, while you still, by virtue of the proximity from the origin of the request, have a decadent, indulgent, ridiculous 10 seconds to luxuriate in, right? Now they have to return in 2.5 seconds. So you can see the problem with timeouts. They're not really fair if they're being used to create or maintain an SLA. So the question is, what can we do to guarantee a response within a reasonable amount of time? Well, here we can use operators. There's a pattern called hedging. Right? Hedging. And so the idea is I want to hedge my bets. I don't want to put all my eggs in one reactive basket. Instead of making a call to one host and port, I'm going to instead make a call to one service, make a call to another service, and another identically configured instance of that service on another host and port, and maybe make another call to yet another identically configured instance of that service on yet another port. And I'm going to do all of this at the same time in concurrence. And the first one that responds, I'll keep that one. That's what I want, right? I want to keep the fastest response, and I want to dismantle the slower of the three results that I got. So this is called hedging. Okay, so I'm going to use back pressure to cancel the other two, and I'll keep the fastest one. Imagine trying to express this using regular Java threading primitives. It's not going to be fun. Remember, there's only one person who truly understands how to write multi-threaded Java code, and it's not you. It doesn't matter who it is. It's not you. That's the important bit here, friends. It's not going to be you. So don't bother. Just let the framework do it for you whenever possible. There's a lot of hair to be lost and very little time in which to do it. I say we should avoid both of those. So let's talk about how that would look. Let's suppose I have a call to order service 1, okay? No, and again, to do, right? I'm calling host 1, and I'm going to call host 2, and I'm going to call host 3. Now, obviously, I'm just assuming 3 static hosts, that's a little ridiculous. You might use something like Spring Cloud's discovery client to programmatically look up through the interface, through the directory service, a number of instances, a sampling of your total number of surface instances, for example, maybe 3 or whatever, and then just randomly route the request to all 3 of them at the same time. But for our purposes, let's just assume I've just got host 1, host 2, and host 3, okay? And now I want to make the same call to all 3 of them, and I want to keep the fastest one. Well, there's cyclic barriers and countdown latches, and I'm going to launch threads, and I'm going to join on all 3 of them when they come back. If they come back, hopefully, who knows? And then if that doesn't happen, I need timeout. So it gets tedious, but I can just do this. I can just say, I want the first one, right? So this is kind of like the select function in low-level C or POSIX, right? It's just me saying, give me whenever the first one returns something, let me know and I'll keep that. So the stream that we get back represents any one of the 3 that actually returns, and it dismantles the other 3, or the other 2 rather. So now I have the fastest one, and I can hopefully meet my SLA. Now, of course, keep in mind, friends of friends, that this only works for idempotent endpoints, right? You don't want to do this for the charge the customer credit card endpoint, because of course you'll get some unhappy customers if you've charged them 3 times. Clearly not a great idea, but it does work, right? It's a very useful pattern. So Google talks about their use of this kind of pattern. Netflix, of course, talks about their use of this kind of pattern, right? Uber talks about their use of this kind of pattern as well. I'm a little skeptical of the whole Uber thing. Remember, they're using a lot of Node.js there, so they don't actually have threads, which is awkward. So I feel like this is just a bit of a Band-Aid for them, as opposed to an actual pattern. But the rest of them have threads, and they know what they're doing. So this is, it's a real pattern. Just, if Uber counts, then it counts. If it doesn't, that's okay. There's still plenty of other inspirational organizations that you might research. Okay, so hedging, good stuff, right? Very easy to express. There's all sorts of other things you can do once you can see that we have the ability to rewire the way that these reactive streams are composed together while still maintaining the integrity of the interface. It is still just a publisher of T, where T is an arbitrary generic type. So I have now the ability to make service calls. I have the ability to rewire them. And that's because what I'm doing here is I'm creating a pipeline. I'm creating a pipeline, and I'm describing how these things flow together step by step in this pipeline. And this is the sort of this is what I was talking to you about before when I say it's got these operators, right? These operators give you a rich vocabulary with which to describe streams of data. And you saw I can use flex.just, and I can create a stream that has one record in memory, or this could be a thing that comes back from a network call, right? It could be anything. So flex.just, this static. There you go. I can do all sorts of things, but ultimately I'm just dealing with a publisher of something. And if I wanted to actually materialize the data in this stream, for example, right, I would actually have to say subscribe. And that's the important part here, is I need to subscribe, just like I need to have a terminal function with the Java 8 Streams API, like a for each or something like that. I need to subscribe to force the reactive streams to start processing. So if I describe this reactive stream today, I can just let it sit there as a Java variable in my class or whatever for a week, and then I can call subscribe. In the meantime, nothing's gonna happen. There's no data that's gonna be conducted across the network until I call subscribe. So the subscription is very important, but it's also very useful because it means that we've decoupled assembly time from execution time. And that means that we have plenty of opportunities in which to rewire things in between the initial assembly and the ultimate execution. And this is particularly useful, as you can see, for things like this, where I'm actually rewiring the operators in a particular way. It's also very useful for service orchestration and composition. And this is where reactive APIs really come into their own, right? So service orchestration and composition, okay? So what I can do here is I can say I want to call, let's say I want to call two other services, order and customer, okay? And we know that the type here, customer, let's see, what is it going to be? It's a, I guess it'd be a list of customer, right? So it's a list of order, right? So orders, new array list, okay? So I want to arrange it so that I get all the customers and all the orders, but these are of course two different microservices. The orders live on one service and the customers live on yet another. So I can imagine having a client like this, CRM client where I can return a mono of customer, get customers, or no, actually I want all of the customers, right? So I'd say, give me all the customers, get customers, right? And I would have another service to give me all of the orders for a given customer. So order, get orders for customer, right? And here, just again, we're using an interface. It doesn't really all that much matter right now how these things compose or how these things actually get implemented. What you need to know is that once I've got that interface, let's suppose I've got an instance of that interface here. I can now CRM client equals null. We'll just leave it to you to implement that, or we'll see that later. And now that I've got this client, I can say CRM client dot give me all the customers. And what that gives me is a reactive stream of customers. And what I want to do is now for every single customer, I want to create a thing that also gives me all of the orders, right? And I want to do this concurrently because again, I'm making a n+1 network call, right? This is unavoidable in some cases, but at the very least, if you're going to do n+1, you should at least do it concurrently, right? Especially if it's embarrassingly parallelizable like this is. I don't need to get each set of orders for each customer sequentially. There's no reason. I can just span out as much as possible and get as many orders for as many customers at the same time as possible. And so this is very trivial to do with Reactive APIs. I'm going to say, okay, for each customer, I want to visit each customer, and I've got the customer, and I'm going to turn the customer, and I want to turn it into something called a tuple, right? So what I'm going to do is I'm going to say flux.zip, and I'll say mono.just customer. So I'm creating a reactive stream with a single value in it called the customer, and then I'm going to say CRM client dot get customers, or get orders rather, for customer, and I'll pass in the customer.id. Oops, I need the ID, don't I? So customer string ID, not dependent injection, ID. Okay, so now I'm saying, give me the orders by their ID. And the result of this, friends, is a reactive stream, each element of which is a tuple. It contains just two values, two typed values. One is a customer, and the other is an order, right? What I actually want is a list of orders. So here, I can say collect list, right? And now I've got a list of order, right? So now I've got a tuple, I get a stream, each of which has two elements, and now I can aggregate that, right? This is what we want when we do static scatter gather kinds of service orchestration and composition. Now I can say static class customer orders, and it'll be a, there's a list of order, new array list. That's where I should have put this type up here. I should put it in that class, in the aggregation type, right? So we want that, and we also want the customer, okay? So we have these two types, and now I want to create the aggregate type. So I go visit each one of these. I'll say tuple to flux.map tuple new customer orders, and I can just pass in. Let me create a constructor here. Data. Okay, there's this. So it's tuple dot get T1. T1 is my customer, and tuple dot get T2. That's my list of orders. And now I have a reactive stream of custom orders, and I can give that back to my web service. I can use it for WebSockets. I can send it over Kafka. I can do whatever I want, right? It's just a stream of custom orders. But now, behind the scenes, because we're using reactive APIs, and because there's this notion of a scheduler, I'm doing fan out. I'm actually concurrently making these network calls to get all the orders as fast as I can. And as results start coming back, I start materializing the reactive view of that data, and I start returning it back to the client. I don't have to wait. There's no serialization here. I don't have to do any weirdness with thread pools or executors or anything like that. I just write code using this functional style, just as I would with the Java HTML API, and I get code that is inherently as resource efficient and as concurrent as possible. This is why I like reactive APIs. It gives me a better way to describe the interactions between services, to do scatter-gather kinds of composition, and to do so in a reliable, robust way. So ideal for microservices. And this is no wonder that Netflix and large organizations like them, like Alibaba and so on, have, first of all, converged on Spring, and then second of all, converged on reactive APIs with Spring. And they've been doing it for a long time. This is why large services care about this stuff, because it allows them to build a more robust, more concurrent, more resource efficient APIs. So now, what does all of this have to do with RSocket? Well, all this time, when we talk about microservices, I think in most of our heads, we imagine HTTP. And I like HTTP. It's certainly a network protocol, right? It has the benefit of being a network protocol. It is not a great service protocol. That's where we get into trouble, right? It's a fine document retrieval protocol, but I don't know that it would be a great service protocol. Obviously, the internet is an existence proof of how scalable it is, but can it be quicker? Can it be more responsive? Can it be more robust, particularly for service-to-service communication inside of an organization, inside of a data center, for example, for otherwise homogeneous services? And I think the answer is most certainly it can. And there's, it's not a controversial thing to suggest that. Obviously, Google very famously tried to take HTTP and they improved upon it with HTTP2, and then they built gRPC on top of that. And so gRPC is a leap forward compared to HTTP2, which is itself a leap forward compared to HTTP 1.0. But gRPC, it fixed some things. First of all, it made it so that you can do binary. HTTP2 implies binary data if you want it, which is more performant, right? Less porous, less textual. That's useful. It gives you pipelined, multiplexed connections. So I can now have one socket that's handling multiple requests as opposed to one socket that's handling multiple requests to the same, pipelined HTTP endpoint, right? I'm not queuing it up. I'm actually just making multiple in-flight transactions on the same network connection. That's good. But it's still a fairly limited thing, right? HTTP is still, at the end of the day, a request response mechanism. It forecloses on the possibility that we could do some of the things that we as architects have always been able to do before HTTP, right? So bidirectional communication, right? Fire and forget. Just be able to say, here's a message. I don't care about the response. I'm not trying to acknowledge it. I just want you to have it if you want it, but I've got to move on, right? So that's a very common thing. And it's a very useful optimization, especially in building the performance systems and software. So there's some of those limitations. gRPC itself has some limitations. It implies Google protocol bus. It implies a binary protocol, which is fine if that's your bag, but I'm not sure most people want to have to write IDL. I personally am not a huge fan of SOAP, nor am I a big fan of Corba, right? Because I'm just tired of having to define my APIs in terms of something else besides my APIs. I want to be able to think about my APIs. It's hard enough to get that right. So I don't want to be beholden to Google protocol bus. I do want language agnostic sort of applicability, of course. I want platform agnostic APIs. And so this is why I like messaging, right? Nobody says that RabbitMQ is a Java API. It isn't, right? It's a protocol. It's a binary protocol. It has an envelope and has headers and it has a message payload. RabbitMQ is a message queue. Obviously, it's an extra piece of infrastructure, not the same thing as RSocket. But because it's a network protocol, we can use it indifferent to what platform we're using to connect to it, right? You can use C++, you can use Go, JavaScript, PHP. Ugh, don't use that. But you could, in theory, right? Lots of things you could use to talk to RabbitMQ. Likewise, because RSocket is a binary protocol, I can use it from any language for which there's a client, or I can just run my own client since it's open source, right? And there are dozens of clients out there, right? The most obvious ones that we care about, of course, are JavaScript for the front end and Node crowd, C++ for the sadists, and the Java JVM binding, right? So when RSocket was created, it was meant to be cross-platform, payload agnostic, and messaging centric, in the same way that RabbitMQ is messaging centric, right? You're not coupling yourself to a particular API. You're just sending and receiving messages. You're using reactive APIs. So RSocket improves upon gRPC, improves upon HTTP 2.0 and 1.0, and it improves upon things like WebSockets, which you might think about as an alternative. And WebSockets are a pretty good first start, but they're missing basic things like, headers, HTTP headers. How are you supposed to communicate out of band information like a security token if you don't have a header? This is a problem. So none of these issues bedevil RSocket. And this is, I think it speaks to how robust RSocket is. Now, RSocket was a protocol that was developed initially at Netflix by engineers who worked on that, who then went to Facebook. And at Facebook, they have open sourced it. Has become a critical part of their backend infrastructure. And they built 3 clients. The Java client, the JVM client for the RSocket protocol is built on Reactor. It's the same reactor I've just talked to you about, right? And so RSocket has become very, very useful, but it was obviously useful for reactor using communities like the Spring community. And we thought, gosh, wouldn't it be nice to integrate that with Spring? And so we did. And so that, my friends, is what we're going to see. Is we're going to see how RSocket fits into all of Springdom and how it can help us build better services faster. So let's start anew. And you know, I thought I was going to show you HTTP, but there's really no need to. That's nice. We can move beyond that. Goodbye. Okay, so the only thing that may not work today is RSC. You know what I remembered? I forgot to check and see what happened to that. That used to work, so I won't show you that. I gotta remember not to show you something called RSC, service application.class, args. Alrighty, good stuff. So there's my new public static void main Spring Boot application. And what I want to do is I want to create an application that reactively provides an RSocket endpoint. So, simple thing. I'm going to create a service, a greeting service. And this greeting service is going to return a stream of greetings responses given a greetings request. Okay. And obviously I need these types, so I'll create those here. I'll say class like that, class greeting request, whoops, request. And the request will be a name. The response will be a message. All right. And I want to now implement this interface, this very simple interface with my service. So I'll say, given a greetings request, I want to return a non-stop, sort of never-ending stream of responses. Okay, so let me make these DTOs. These are going to be the payload that we're going to communicate across the wire. Okay, and private final, we're going to use a, we're not going to use anything actually, we'll just create an in-memory stream of data, right? But again, anything that could be, you could have a chat, you could have stock tickers. I mean, there's lots of things that can produce infinite streams of values, right? So I'm going to say, given a stream, generate new greetings responses given the supplier, and do so by returning a new greetings response. So new greeting response, and the message will be hello greetings request dot get name at instant.now. Good. Hello, computer. Why is this unhappy with me? Good. All right. So there's my reactive stream, my infinite stream of values. Obviously, this publisher, this reactive stream, as written, would very quickly scroll down the floor and out the door. So what I want to do is I want to delay the sequence a little bit. I'll just introduce time, and I can do that because of the aforementioned scheduler, right? The scheduler is the thing that allows us to introduce this notion of time into our APIs. It allows us to say, this is going to run at this time every second, it's going to run every hour, or it's going to run right now. It's also, if you think about it, it's 1/2 thread pool and 1/2 timekeeper or clock, right? You can do interesting things there. So what I want to do now is I want to create a controller, an RSocket controller, to expose this endpoint to the world, right? I'm going to say RSocket, controller, class greetings RSocket controller, okay? And I'm going to say at message mapping, greetings publisher of greetings response. So greet, and I'll take the greetings request. Return, and I'm going to inject my little service here to do that work. So I'll say, whoops. Come on, Josh, you can do this. Private final greetings service. I'm going to inject that into the constructor. I'll take advantage of Lombok. Do I have Lombok? Did I manage to forget Lombok? I got Lombok. Okay. Required args constructor. Good stuff. So now I've got that. I'm going to say I want to just send a message. This.service.greet request, and voila. That's the entire thing. Okay. That'll create an RSocket endpoint. And you know, I'm going to try it. I don't know if they've updated it or not. I had a nice client that worked just fine out of the box all the time, and now it doesn't seem to work, and I keep stumbling into it in the middle of my presentation, and then I forget because it's like an hour and a half later to check out what happened. Okay, first things first. I need to tell Spring to create the RSocket endpoint for me. So I'll say RSocket server port equals, let's say 8888, okay? Second thing, you can see it says using generated security password. Right now, I don't need the security in place because it's just gonna, it'll refuse me access to my endpoint. So I'll comment all that stuff out. We'll use it later. And I think I'm happy with just that. Let's re-import. Let's try again, this time with more gusto. Good stuff. Okay, that's up and running. Now, what I want to do is I'm going to try this client, okay? Who knows if it'll work? R greetings, and it's going to be TCP localhost 8888, and it's going to be stream, and the data that I'm going to send into it is a greetings request, and it'll be a greetings request with a name, NY Java SIG. No, localhost. Why is that? Stack trace. See, I can connection timed out. I don't understand that issue at all. This is a new issue. I have no idea why it's a change in the client. That's okay though. What we're going to do is we're going to build a client to talk to our service. There's a lot of other ways we can build a client. Usually this RSC command works just fine. Something has changed. It'll be fine again as soon as I can figure out what it is. It's a curl, if you will, for RSocket endpoints. That said, I want to build a client to talk to it. Now, there's a couple of ways we could do that. One is, I think, worth exploring, but it's probably not going to be our default approach, and that is to use Spring integration. Now, Spring integration is, well, actually, I already, here, refresh. Okay, so Spring integration is a way to build pipes and filters enterprise applications, right? It's a way to build pipelines that are meant to integrate otherwise disparate services and data, right? It's patterned after the amazing seminal tome by Gregor Hope and Bobby Wolf called Enterprise Integration Patterns from 2004. It's a real page turner, my friend. It's an amazing book. It's like 700 pages. I read it to the kids, keep it under the pillow. It's amazing. Really, really a great book. Now, that book talks about how we can integrate otherwise sort of unintegrated things that are sometimes hostile to integration, right? And it's a very interesting book, and it makes, if you read the book, you kind of walk away with the sense that whenever possible, I should use asynchronous messaging for integration, because I can simulate synchronous interactions with an asynchronous API, but not vice versa. I can't simulate asynchronous if the Java types I'm using, they imply asynchronous APIs. I'm 12 floors up, and every night at this time of night, there's a road traffic as people are getting onto the Bay Bridge, going back to wherever part of the world they live in. Okay, so we have Spring integration. We're going to use Lumbuk, and we're going to use RSocket. Okay, we're going to hit generate. That'll give me a new project. Integration. And in Spring integration, you have this concept of a pipeline. Like I say, you adapt data from the outside world. You process it by transforming it, by filtering it, by routing it, by enriching it, by aggregating it, etc. And then you ultimately write it out to something using an adapter as well. So inbound adapter, outbound adapter, and then processing in the middle. Or sometimes you might have a little bit more of a sort of a request response kind of flow where the message comes in, you do some work with the message, and you send it back out. That's called an inbound gateway. The other way is you might send a request out to some other service and get a response, in which case you've got an outbound gateway. So inbound adapters are unidirectional adapters. They take things from the outside world and turn them into Spring Framework messages, each of which has an envelope and a payload. And outbound adapters do the same thing in reverse. They take a Spring Framework message and send them into the outside world. And then the gateways, they take the message, send it out, and get the response, turn it into a message again, or vice versa. Okay, so integration is a great way to integrate things that don't know or want to talk to each other. So, for example, there is no reactive API to do file system access because you can just use asynchronous IO, right? That's fine. But ditto, there might be some service for which I don't have a reactive API. And so you can use integration to write the glue code in kind of an elegant way to make these things talk to each other if they wouldn't otherwise. So what I'm going to do is I'm going to create an integration flow that depends upon Spring Integration's file and RSocket support. So we'll go here, dependency, Spring integration, RSocket, okay, and file. Good. So there's my RSocket and integration support. And now I'm going to use this to create a simple Spring integration flow. I'll say Spring integration flow, integration. Okay, and we're going to say integration flows.from. And here I need to define the file inbound adapter. Files.inbound adapter. I'm going to provide it a directory. And I'll say I want to inject a value from Spring. I'll say give me a pointer to a file system that's resolved through an environment variable called home, right? Desktop in file in directory. Okay, I could also ask for a path, I suppose, doesn't matter. And I want to auto create the directory if it doesn't exist. Okay, and I'm going to say file inbound adapter. Now, of course, file systems don't have a way of telling me something has changed. I really need to ask it, most of the time. So what I'm going to do here is I'm going to say to the inbound adapter, I'm going to say, please poll the file system every, let's say, 1 second. Okay, so here I say I'm going to configure a poller metadata, PM, and I'm going to configure it at a fixed rate, or I could use a cron or a fixed delay or a custom trigger, which could be, it could trigger the heartbeat, the poller to beat every second, every nanosecond, every 5 years. You could have it read from a database or whatever. But for my purposes, I'll just use fixed rate 10. Okay, sorry, 1,000. That's a milliseconds. Okay, and once I've got that data, I can handle it. Right, I can actually do something with it. So I'm going to create another handler here, and the data that comes in from that will be a file. Right, so I'm going to log the file out, and I'm just going to prove that everything is glued together correctly. That we've got what we expect is to happen is actually happening. So I'm going to log out the path, and I'm going to log out the headers, each one of them. So I'll say kv system out kv. Good stuff. So let's see if that works. Simple program. We'll start this up. I'll let that start up. Okay, good stuff. So let's see. What we're going to do is put a file in that directory just to make sure it's all working. cd desktop in cd in echo hi ny java sig. Okay, oops. And there's the response. We couldn't really see it happen, but let's try again. Echo again, right? And there's the file being processed again in Spring Location. Okay, so the basic flow is working. You can kind of see the program model. So now let's integrate it with our RSocket endpoint, our RSocket service. So let's create the RSocket gateway. Okay, so we'll say var RSocket gateway, RSockets.outbound gateway. And here I need to provide the route. That's greetings, right? We saw that before. And I need to provide a few other things to make this work. I need to provide a client RSocket connector. Okay, so client RSocket connector. Bean client RSocket connector. Var CRC new client RSocket connector. And here I'm telling my Java code how to connect to the instance of the RSocket service. So, and I also need to provide it the RSocket strategies object. That's an object that Spring Boot will automatically customize for you to if you want a sort of a digest of everything that's being done to configure encoding and serialization and security and all that kind of stuff. There's all sorts of stuff that gets plugged into that one object for Spring Boot and for Spring. So anywhere in Spring where you need to say, here's how RSocket's doing everything it's doing, you pass around that RSocket strategies object. Okay, so I've got my client RSocket connector. I want to inject this as a dependency on my integration flow. CRC, okay. What else do I need? I need to specify the expected response type, right? Remember, I'm calling the greetings endpoint. What data do I expect to be returned? Well, I expect a greetings response, don't I? So let's go back here, and we'll take the greetings request and greetings response DTOs, copy and paste them, and voila. And now I've got a greetings response dot class, right? The other thing I want to specify is how I expect to interact with that service. So in RSocket, you have fire and forget, you have request response, you have request stream, where you request a certain, where you send a request in and you get a stream of values back, or you could send a stream of values in and get a stream of values back. So that's called channel. So I need to say that the interaction model is a request stream. I'm sending a single value in, but I'm getting multiple values back, okay? So I'm sending a file name in, and I want to get multiple values back. So now that we know that this works, let's adapt it. Let's say, okay, when the file comes in, I want to transform the file object into a string. So I'm going to use a new file to string transformer. And then once I've gotten that, I want to trim it and uppercase it, okay? And then once I have this, I want to pass it to the outbound gateway as a greetings request. So I need to transform it yet again from a string to a new greetings request, passing in the name. And then finally that I'm going to transform, or I'm going to handle rather, by asking the outbound gateway, the RSocket outbound gateway, to send that to our service and give me a response back. Now, the response back that I'll get at this point is a single, it's a publisher of greetings response, right? So I don't want a publisher of greetings response. What I want is a single greetings response, right? I want to split the reactive stream into individual values there. So I'm going to do that. Now the thing is, when I split it, I'm also going to have a, I'm going to have potentially more data that I can handle, right? Spring integration isn't reactive by default. So I'm going to have more data that I can handle perhaps. And so in Spring integration and in the enterprise integration book, we have this concept of a channel. A channel is a named conduit through which messages flow. It's implied in most of what you've seen here. There's an implied channel from here to here, right? Or from here to here. But channels are very important. They're basically queues, right? In Java, by default, they're just Java util queues in memory. But you need that when you build staged event-driven kinds of architectures. You're buffering the output of one component before delivering it to the next, right? And so what we want is for our queue, our channel, to be back pressure aware. Not only should it buffer it, but it should know also how to push back. And so there's a DSL that we can use to create a reactive back pressure aware message channel. So we say message channel, back pressure aware message channel, return message channels dot flux. Okay, there it is. There's my channel. And I'm just going to use that here. I'll just inject it into my bean definition there. And I can now use that. I can say, okay, split it, but then pass it to this. Message channel, there you go, message channel. And then finally, after that, finally, I get the response back. I can say new generic handler of greetings response. At this point, I'm not dealing with any one thing. I'm dealing with a greetings response. And now I can print out the results, right? So system out print line, new greeting response, payload dot toString. And, you know, same as this, right? The headers for each KV, system out KV. Okay. All right, so let's try running this again now that we understand the entire flow. So file in to a string, to uppercase, to a greetings request, to the RSocket endpoint, to a reactive stream that comes back, to a thing that we just print out. So let's go ahead and run this one more time. Oh, okay. There's multiple channels in the context. This might fix it. Let's see. Worst case, I can just invoke the method. That would make it very clear as well. Okay, good. So there you go. You can see every message. Hello, hi, blah, blah, blah. It saw the files in the file system. And so it's going to send me a never-ending stream of responses in perpetuity every second, forever and ever and ever. So that's one way to connect your client to your services, right? Spring integration is pretty amazing. It gives you a nice pipes and filter centric way to talk to RSocket services. But for most of our applications, we're not going to do that. Most of our applications are going to be kind of like the service itself. They're going to be RSocket services and clients and so on. So we're going to use RSocket again. We'll use Spring Security again. We use Lumbuck again. Okay, Java 15 because we can. It's the future. And what else? I think that's it. I think that's probably enough. Do I need anything else? I think that's it. Okay, let's hit generate. And can I do that? Good. CD downloads, UAO client.zip. Okay. Alrighty, client application. Good stuff. So there's my application. And what we want to do here is we want to act as an RSocket client to the other RSocket service. So I'm going to build the reactive RSocket client here using the RSocket builder. Now, a couple things to keep in mind about the RSocket protocol. First of all, it is a stateful protocol. So when a client first wakes up and it wants to talk to a service, it connects one time at the very beginning of the application's lifetime. And that's it. Once it's connected, it stays connected for the life cycle of the application. It's multiplex, so I can send multiple requests through the same network socket. This helps save on the slow, tedious, very unnecessary, constant back and forth of setting up a network connection, hacking the connection, and then doing the work and then dismantling that connection, right? Very inefficient when you talk about HTTP 1.0. So what I want to do here is I want to use that to create an application listener. Ready, okay. And I'm going to inject that RSocketRequester. Okay. So requester.route greetings. And I'm not going to send any data in. I could actually say this has got a, locale or whatever, and I could actually provide a parameter there, and then the second thing I would provide would be like, JP or whatever, right? You could do that. But my URL doesn't have any path variables expected, so I'm not going to, or destination variables is what we call them, so I'm not going to use it. I'm going to say that the data that I'm expecting back, as before, is a greetings request given a greetings response. So I'll say expect a greetings response, and I'll send some data in. It'll be a new greetings request, and I'll say ny java sig, okay? And once I get that, I'm expecting the data to come back, and as it arrives, I'm just going to print it out. I'll say system out print line, okay? So this is a very simple interaction here, right? I'm just making a call to the downstream service using the RSocketRequester. Let's see what that does. Oh, this isn't going to work. You know why it's not going to work? Because there's nothing keeping the service from starting and stopping quickly. So let me quickly read from standard in here. Okay. Unsupported class file. Well, that's a bummer. I didn't know there was an issue with Lumbuck in Java 15. Back to the safety and serenity of Java 11 I go. Okay, take 4. Seems happier. There's my infinite stream of responses trickling out in the console in perpetuity forever and ever and ever. And again, this is okay because one of the core conceits of reactive APIs is not that we're going to be did I miss something here? Yo. Not sure what all is going on. Do I have a PSA? Oh. PS. Print out. Kill -9. Rep Java. This one. pkill for some reason just doesn't seem to do a great job here. Good. All right. So take 4. Start the service again. I think I had some other network service running maybe. Okay. Take 3. Okay, that looks more like it. It's progressively moving, which is what it should be. This is the core conceit of reactive APIs is not that we're trying to make any one transaction faster. What we're trying to do is make it so that we can handle a good deal, many more transactions at the same time. So any one particular transaction might be just infinitesimally slower than in an asynchronous sort of blocking scenario, but I can handle many more of them. That's the important bit here. I get better bin packing capabilities, if you will, with my operating system resources. This is ideal in a containerized sort of cloud native world. So I've got a simple client here, and let's be honest, this is not a very interesting, it's basically I'm sending a request in, getting a response out, and it's not interesting code. Nobody wants to write this kind of code. So I actually worked on a little project here that you might find interesting. Who knows? It's an experimental, very important, not yet worthy of production, right? It's I would regard it with the same skepticism, the same hesitation, the same lingering doubts and fear with which you regard PHP, right? Not for production, definitely not there now. The difference is that this will eventually be worthy of production, whereas, well, PHP won't be, right? So I'm going to copy and paste this URL here, and actually I don't care about the URL, I care about the documentation. And here I've got the basic setup information. What you need to know is you need to have the dependency here. Go to the build, add the right version. The version is 001 snapshot. Paste. And of course, the project is not yet GA, so it's in the milestone and snapshot repositories for Spring. So you have to bring in those bits as well. But once you've done that, now you can actually just enable RSocket client. So you say RSocket, hello, refresh please. RSocket clients, okay? And then you can build a client. So interface, greetings client, greeting client, publisher of greetings response, greet, given a greetings request. Okay, and I'm going to map it to the greetings endpoint. And I'll just say that this is an RSocket client. Now this gives me the same exact result as me writing this manual code here, right? But the difference is now it's just an interface. I can, if I want to socialize a client to an API, I can just provide this interface, and I can also provide filters and so on, so that I can customize things. So let's actually look at how that one would work. Okay, good. And this is called RSocket. So we say return event, and we get the greetings client here. So we say now client dot greet new greetings request ny java sig from RSocket. Okay, and I just expect the results to come back, and I'm just going to log them out just as before. Alrighty, good stuff. So there's this. And I'll comment out this one so we don't have noise. Run this. So there we are, my friends. 2 different ways to talk to the downstream service. That said, RetroSocket is really only for a client sort of interaction, right? It's not meant for some of the more nuanced and more interesting things you can do with RSocket. So while I love it as its creator, I'll be the first to say it's kind of limited. It's just if you want to treat RSocket like a very, very nice gRPC or a very nice RMI or something like that, you can, and you can even have declarative, you can have a declarative Netflix OpenFane or retrofit style interface-based clients in that approach. Very convenient for getting up and running quickly. That said, it would be mistaken to treat RSocket entirely just like a request response mechanism. Okay, one of the really interesting things that you can do with RSocket is bidirectional communication. Right. So let's suppose I have on the client here. I'm in the client when I'm making this data request to the service. On the client, I want to know something. I want telemetry or some sort of feedback from the service. Okay. Now, this is strictly speaking not strictly required if you don't want it to be, but one of the things that is interesting about RSocket is it was built with operations in mind. It was built to be production ready. And so when they built it, there's several things they did. First of all, as a network protocol, it is back pressure aware. So on the wire itself, I have a message frame to push back if I want to, right? This you can't do with HTTP, right? HTTP is a one-time kind of thing. I can make a connection and I can get the data, or I can disconnect. Once I've disconnected, once I've stopped processing the data, I'm done, right? There's no more like starting again later on. With RSocket, with Reactive Streams API, as you saw earlier with the subscriber, there's very much that implication that you could do that. That's a thing that you can do. You can pause your work. You can say, I want to ask for 10 records and then not request anything more. That doesn't mean you've disconnected. It doesn't mean you've canceled the processing. It just means that there's more to be consumed, but you haven't requested it yet, and therefore it hasn't been given to you yet. This is session resumption, right? So that's implied in the Reactive and the Reactive Streams APIs. RSocket supports that as a protocol. It's not just a good idea. We can't do that with HTTP. Remember what happens with HTTP. Imagine you connect to an HTTP service, even when built with Reactive Spring Web Flux, right? The best that we can do is if you have a Reactive Spring Web Flux HTTP endpoint to which a client, any client, curl or the Reactive Web Client or HTTP, command line, CLI, whatever, any client, the best that we can do is when that client disconnects, our Reactive Spring Web Flux service perceives that disconnect and automatically cancels the streams that were being used to produce the response. It transitively applies back pressure to everything involved in producing the response for that client. But that's it. It's a one-time thing. It's a one-time back pressure. You can't ask for more. You have to reconnect and start anew. So that's one thing that I like about RSocket in production. Another thing that it does is that there's actually a message frame in the protocol for communicating health and telemetry and arbitrary stuff, right? So it's kind of like the Spring Boot actuator. I don't know if you've ever used the Spring Boot actuator, but the actuator are a set of managed HTTP endpoints that you can have mounted at a path underneath your application, and they articulate things like the health of the service, the uptime, the metrics, whatever, things that you can use to decide whether this service is worth your time should you try and request it to give you something, right? You might, as a smart client, load balance yourself away to another node that's better able to handle the request if you perceive that the actuator says it's too overwhelmed, too deluged. This is a very nice thing, but it's hardly a standard, right? It's part of the Spring Boot community, and granted we are millions strong, but that's not the same as requiring it for HTTP, right? There's nothing in HTTP that requires that services have a managed endpoint to which all clients can connect to ask it questions, interesting questions about its fitness to be able to respond to a particular request. That's nothing there. Would that there was, but there's just not. Well, RSocket has that in the protocol itself. So this example I'm going to use here, just imagine you've got something you want from the service besides health, right? Maybe you want telemetry, right? Maybe you want to send, maybe you've got some sort of state that's on the service and you want to use that state to determine whether the client should continue processing the data, right? Or rather the other way around. You want to determine that state on the client to determine whether the service should continue processing the request, okay? So what I'm going to do is I'm going to create an RSocket endpoint here on the client to which my RSocket service is going to connect. So at this point, it's no longer clear which is a client and which is a service. And this is why when you look at RSocket, you can see it says RSocketRequester, not client, because in the RSocket world, either side can initiate the conversation at any point. One side can be a requester and the other a responder, but either can be each at any time. There's no clear distinction. Neither one is stuck in that role forever. And indeed, the one connecting to the other is not the same as one making a request of another, right? Either one can connect at any time, and either one can initiate the conversation at any time, okay? So what we're gonna do is we're gonna customize our RSocket requester here. And the RSocket requester is going to need a socket acceptor. So we'll say socket acceptor, RSocket connector rather. And we're going to need to configure this. So we'll say connector dot acceptor. And I need to configure a bean of type socket acceptor. So socket acceptor return RSocket message handler dot responder. And again, I'll inject the RSocket strategies here. Strategies, and I'll reject the content, the actual controller that I want to create that'll provide the response from the request coming from the service, from the thing that's actually the center hub of our architecture, will actually ask our client questions. And so in order to answer those questions, I'll create yet another client. And this client will return the client health state. Okay, so client health state controller. And we're going to use a detail that I'll create here for our demo called client health state. Private string, private boolean healthy. Okay, so at data, at all_args constructor, at no_args constructor. And we're going to create a new endpoint here. It's just going to be an arbitrary, endpoint here, just some fake data. Client health state, health, flux.from stream, stream.generate new client health state, math.random is greater than 0.5. So it'll be basically I'm going to be returning. I need a supplier there, so I'll be returning healthy, 50% of the time. And the first time it's healthy, the first time it's not healthy rather, I want to stop the production of the data. So my client in the architecture is going to send a stream back to the service, and the service is going to constantly monitor that to say, hey, is the client still healthy? 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 If it is, it'll keep sending greetings. But if it's not, it'll stop because there's no point because the client is, for whatever reason, saying, hey, I'm doing something else or I'm busy. And I'm using this as a very simple example, but imagine the user has disconnected or they've put pause notifications or whatever, right? That's what you would use this kind of thing for. Okay, so now I'm going to inject that. I'll say client health controller. And there we go. There's my RSocket requester that's been customized now to be aware of this bidirectional communication. So now I can restart that in a second, but what I want to do here on the service is rewrite that code a little bit so that I'm now aware of this health endpoint. So first things first, I'm going to take this client health state, put that as a client-side DTO on the service side. And here, I'm going to change my RSocket service endpoint here to be aware of the incoming RSocket that's making the request. And I can do that by asking Spring to inject the client RSocket connection, right? I can get a pointer to the client RSocket connection by injecting the RSocketRequester there. Not bad, right? I can actually use that to ask questions now. And Spring will do that. It'll say, okay, I'll inject that for you. So here's my stream of greetings. Let's see what that gives me. That's a stream of greetings response. I'm going to ask this for health data. I'm expecting back a stream of client health state. Okay. Now, of course, I don't want any I'm going to filter out all of the health that is healthy. So if it's healthy, I don't care about it, right? I only care about it if it's not healthy. So I'm saying call that endpoint, get all the data back, and as each record arrives, evaluate whether it's healthy or not, right? And what I'm doing is I'm saying if it's not healthy, then I want to know. And up until it's not healthy, this will be empty, right? Because the results it'll go through the filter, and by the time it gets to the other side, the result, this reactive stream will have no elements in it forever, right? Until suddenly this is not healthy. And so while it's empty, I want to keep sending back greetings, right? So here's how you write that. This is pretty involved concurrent code, but in the Reactive API, again, pretty trivial to do. So I'm going to say greetings, take until other health. Okay. So that's it. That's the way you say monitor this volatile, intrinsically busy, ongoing thing over here. As soon as there's something I should care about, stop streaming. Okay. Now we can restart the service. Okay. Oh, it's up and running. That's too fast. Oh, acceptor, right. Yeah, culpa. Compilers. We don't need no stinking compilers. Look at that. All you do is ruin my day. Okay, here we go. Fingers crossed. So, connection refused. Did I miss something obvious here? Oh, I didn't see this happen. You can't see it. I'm not sure if you can see it, and I can't zoom in because it doesn't work on Zoom, but ironically. I didn't fully restart. Sometimes Netty-based services don't give up the ghost. They cling to the port, and you have to force them to restart. And this is why occasionally you'll see me go into my command line and p-kill errant processes because Netty. Okay, so now that's restarted. That's why it felt so fast. I didn't even see it restart. I was like, oh, it's already up and running. I can't drink coffee. Okay, so it's up and running. Did we not get, okay, hold on. I want to make sure I've got nothing running, first of all. Okay, part 1. Part 2, start this. Part 3, I want it to be a little bit harder to fail here. So on the client, where's my controller? I'll say it's going to be unhealthy if math random is greater than point, let's say 8. So it's healthy if it's, yeah, there you go. So if I understand that right, that should be unhealthy 20%, a little bit more than 20% of the time. Greetings. Retrieve, okay, calling the health endpoint, getting the health state, route, retrieve data, client health state. If it's not healthy, greet, take and tell others. Is it just bad luck? Let's just try again, I guess. Client health. Okay, wait, let's just try this for a second. Just return the default without the take until. Make sure I'm not crazy. Okay, seems fine. So take until other health. Seems reasonable, right? At the publisher. And I want to print out do on next chs dot is healthy. So there's the service. Try again. It'd be sad if I'm actually just getting the really bad luck just every single time. This is why I don't go to Vegas. I can't even win a coin toss. Let's see. Here we go. Come on. Take it. Okay. I'm missing something obvious here. When in doubt, try the silly stuff first. So 11.11. 2.34, yeah. 2.34. Usually, okay, what is going on? So let's just try always healthy, right? That'll be true all the time. And in theory, I should just have a never-ending stream, right? So restart this. What? Is it getting here? Greetings, health, blah, blah. Take until other, system out, health. I mean, I just want to see that it gets that far. I'm not even sure what's going on. Okay. Up and running, good, happy. Take 3. It got to that endpoint, isn't that funny? Take until other. Well, no idea, friends. That's a weird one on me. The only thing I can possibly think of is that I've inadvertently bumped into something that didn't used to exist as an issue. So I will always just, as always, it's always worth going back just to make sure there's no regression introduced somewhere. So rebuild, re-import. And for that matter, if this doesn't work, I can always just go back and check the code. This is why we have the code, friends, to keep yourself with a safety net if you need it. Okay, that's 2.3.2.
Josh, we would like to get some questions in there. So can you
Sure.
let me know when we can jump to questions?
Please throw some questions at me while I fiddle, would you?
Awesome, debugging and questions.
Yeah.
All right. So our first question is, who's responsible for the lower level network that actually does reconnects in RSocket? Right. So
that's
if the network fails, what happens?
So the RSocket our library, the Java implementation, based on Reactor that's part of the RSocket project. By the way, a couple things. Backstory. RSocket is the first fledgling project that a number of us, including the Spring team, including Facebook, including Alibaba, and others, donated to the brand new Reactive Foundation. And so when you ask who's responsible, I know you're talking about technically, but organizationally, it's that foundation, including the Spring team, including others, right? More specifics. More specifically, there's actually, you can configure the RSocketRequester. That's actually, that story for, you can do it, but there's actually a better story now coming for the RSocket client 1.1, I think it is, where it's actually becoming even better from that perspective to get it automatically. Right now, you can do it, but it's tedious. Going forward, and I think very soon, you'll be able to just automatically have that built in.
Okay, cool. So you talked about sort of you use a publisher for everything, but I imagine there's some things you might not use a publisher. How does RSocket handle messaging? So like JMS, MQTT for Internet of Things, AMQP, etc.
Yeah. So the idea is that you will have a perspective of this asynchronous thing, and your perspective is a publisher. A publisher is what gives it to you. A publisher is what gives you the data that you're looking for, right? And so it's the same as just like calling a web service. It's just, I'm calling that web service and I expect to get a stream of results back. When I use the reactive Kafka client, I get a publisher. When I use the reactive AMQP RabbitMQ client, I get a publisher, right? And you can adapt otherwise asynchronous things into publishers as well, right? That's for sure. That's easy to do. But there's already libraries. The thing is, there's already libraries that'll do it for you out of the box. There's a lot of them. So I would try those first before I give up on, you know.
Okay, so you weren't kidding when you said everything's a publisher.
Yeah, I mean, that's why you get consistency. You get ease of composition. It's much easier to glue things together that want to be glued together, right? Instead of having to constantly adapt them.
At the beginning, you showed that you could choose between Java 8, but not Java 8, Java 11, and Java 15.
Yeah.
After Java 11 came out, did you make it the default? Like, was it right away, or did you have some period of time go by? And is that what we should expect to see for Java 17?
So how long was the difference between Java 11
like,
and
did you make Java 11 the default the day it came out, or did you wait for some period of time? And do you expect to follow the same plan for Java 17?
So Java 11 it was not the default immediately, no. But we had it on there's two levels of support. One is, does Spring Boot technically support it, right? And so Spring Boot, we don't want to, usually that happens before a GA release. So we'll have the start.spring.io experience switched over to be able to support it as an optional thing. It's not the default, but it's optionally available. But the Spring Boot project itself, which has new releases every 6 months, by the way, that project itself has to commit to supporting it, because otherwise, what's the point if we put a little checkbox that said you can use Java 17 when it doesn't even compile, right? It doesn't work. So that's part one. So Spring Boot usually is very good about that. They have a new release every 6 months. A big part of that is because we want to make sure that we're always on top of the latest version. So how long you see it in the milestones or the snapshots of Spring Boot, that's usually very quick. You can by the time people are interested in doing it, it's already possible. Then there's the question of how long before it shows up on start.spring.io. It may not be the default, but it shows up, right? So recently, in the last week or two, Java 15 showed up. It's not the default, but it's there. Java 14, it took a couple weeks after Java 15 to get released, after Java 15 was released, for that version to be added, right, to the Spring initializer. So it took a couple weeks even there. So Spring Boot already supported Java 15, but the Spring initializer didn't, right? So there's a little bit of a gap. And I expect that the next version of Java will be available. I don't know when it'll be the default though, but Java 11 wasn't that long, and it was on the initializer. So practically speaking, if you want to use it, it's been there almost from the get-go, right? We released, and that was before, when Java 11 came out, that was before Spring Boot had moved to a 6-month release cadence. So it was even more prolonged the wait, and it was still pretty quick in terms of it being on the initializer as an option.
Okay. You would be disappointed to know that our opening survey says most people are still on Java 8, but alas,
my heart.
Them a little.
Unbreak my heart. Yeah, that's not great.
But back to RSocket. Do you have any suggestions on approaches when you want to use RSocket asynchronously to connect to synchronous cloud services?
Yeah, use Spring integration, right? It'll give you a nice program model to say, here's a thing that's synchronous and I don't care. Here's a thing that's asynchronous and I don't care. I'm just dealing with it in terms of this pipes and filters messaging model behind the scenes, right? That's why I showed you that, is because it's a great way to integrate things that are not reactive, right, with things that are. Yeah, and you can also, if you want to do just pure play reactive APIs, you can totally do that. You can actually create there's nothing technically stopping you from using a reactive API or using a non-reactive API from reactive code. The only thing that you have to keep in mind is that that the work that you do could end up blocking a thread, which is important to avoid. So you want to do that in a separate thread pool. So what you would do is you set up a custom scheduler, right? You just tell it to publish on or subscribe on this particular scheduler, which is nice.
Note to our audience, we have a couple questions left. If you want to get your question in, type it into the YouTube chat now to make sure you get the cutoff. And if not, you can always ask Josh on Twitter in the future. Our next question, I don't know if you're allowed to answer it, but do you know of anyone using RSockets in production that wouldn't mind being mentioned?
Yeah, Facebook and Alibaba. And again, they're using, Alibaba is all Spring Boot and all Spring, and Facebook is using Reactor, which is a Spring project. So, these are non-trivial organizations. That's the only reason I'm talking to you about it. This is not just me saying, oh, I've got a good idea. This is the biggest organizations on the planet are having some success. I hope you will too, right? This is
We're here in New York City where a lot of companies don't like to be mentioned. So
completely fair, but I love the interactions, the dynamic I have with Alibaba is particularly awesome. They've been, I go to, well, again, 2020 being a special year, but every year before this, I'd go to China and I'd go to a little city in China with, a population that's, I think it's larger than New York, probably. What is the population of Hangzhou? Population of Hangzhou, China.
Important data point.
10 million people. So I don't know, what's the population of New York City?
You'd think I would know that.
8.3. So it's a small city in China, but it's a massive city by any North American standard. It's a small city, very tiny, adorable, and that's where Alibaba's headquartered. And I go there and I spend a week, usually something, sometimes longer, sometimes less, but I spend time with Alibaba because they've been using Spring for decades and they're big. They have Spring everywhere. And when I say Spring is everywhere, I mean everywhere. Remember, Alibaba is not one monolithic company. There are actually several companies, all of which are bigger than most American companies, right? So, you've heard about Alibaba itself. They IPO'd recently. Ant Financial is kind of like their PayPal, right?
I mentioned before about hedging and Node.js. Why isn't it possible, and why can't you use Promise for that, or Promise Race for that?
Oh, it is possible, and they do it. But again, originally they were doing it because they didn't have actual threads. They were doing this sort of spitting out a process each time, which is not great.
Okay, and the last question before we turn it back to Sai for closing remarks is during the demo, the demo gods are helpful with everything, and there were a couple of problems that occurred from Java 15. Does that mean that you recommend people not use Java 15 in prod, or this is special in some way we should be aware of?
I'm not convinced that I've actually identified the issue. I was planning on just bulldozing ahead, ignoring this particular issue until I got through because I'm not even done. Java 15, wait. Did you see that? Oh.
We have a piece of demo gods.
I just copied and pasted my own code into a working situation. Okay, so I used the Chinese version of it. So I don't know what I did all differently, but I did something there. And I've got now, there you go, is healthy, logging out, not healthy, greetings response, greetings, client RSocket connection, greetings request, everything's fine. Okay, so there you go. So it produced results until it said not healthy. Honestly, I have no idea what I did differently there. Can I show you one more thing before we wrap up? Actually, I wanted to stick to this down.
So very brief.
1 minute?
Yeah, so be brief.
Seriously, just like 1 60-second period? Oh dear.
Maybe 90 seconds.
Okay. Spring security, good. Spring security helps you secure your application. So what I'm going to do is I'm going to go to my service here, copy and paste that code, go to my build, and I want to lock down my endpoint. Spring Security addresses two concerns: authentication and authorization. Authentication is the question of what can they do once they're into, who's making the request. Authentication answers the question, who's making the request. Authorization answers the question, what permissions do they have once they're inside the system. And Spring Security supports both of those. You configure a web filter chain for Spring Security and HTTP. You configure a payload socket acceptor interceptor for RSocket. And what I'm doing is I'm teaching Spring Security. I'm teaching Spring how to resolve messaging handler. There you go. I'm teaching it customizer with defaults, blah, blah, blah. Okay, go. And customizer with defaults. Good. So I'm teaching it how to secure my RSocket endpoint, and I want to take advantage of that new security by, instead of using the old code, which is just taking the greetings request in the payload, I want to take this new code, and here I'm going to actually take the current authenticated user in the current request body, and I'll use that to produce the response instead. So authenticated principal, import class, thank you, and I'll use the user details. So here I'm reworking the endpoint. So the request is, give me the current RSocket connection from the client and give me the name of the user who's authenticated, and then turn that name into a greetings request, and then call the original endpoint, which has all of our take until logic. So that's the service side. That's the RSocket endpoint. On the client side, I need to do the same thing in reverse. I need to actually authenticate as though I was the as though I'm authenticated, right? So I need to actually do that. And the way you do that is with metadata. And that metadata is kind of like headers, except it's not a key and value. It's actually a value matched to a MIME type. So I'm going to configure this here. Where's my client? There. And over here, we'll paste this. There's my metadata. Come on. And I can use JWT, or I can use username and password. If you use usernames and passwords, it's called simple authentication in the context of RSocket. If you do JWT, then that's a whole other Oprah for a thing for which we wouldn't have time, even if everything had been on time.
Yeah, you used 120 seconds of the 60 seconds. So I got to turn it over to Sai so we can end the meeting on time. Sai, what should we expect to happen next?
Excellent. So thank you so much, Josh, for this very informative talk today. It's exciting to learn about the latest in our sockets and all the work that you have done here. And thank you, Gene, for relaying over very interesting questions from our audience. So great. I think, next we are looking forward to an exciting Java hands-on workshop. It is later this month on the 22nd of October by Matthew Gilliard. And he will be covering two-factor authentication. So that's an interesting topic to look forward to. And I really thank the audience here today for staying back and participating in this talk today. So subscribe to our Twitter handle to know more about the information of the next talk, or head over to our website on javasec.com and subscribe to our mail, so we don't spam you. We just send you useful information when the next talks are. With that, we'll end today's session. I'd like to really thank everyone who joined us today. Have a good evening and have a great rest of the week ahead.